my friends, welcome back. In today's video, I'm going to start a new tutorial on machine learning. In the advanced topics for Python, we talked about, how you can use different libraries, right? We showed you the NumPy library, the SciKit-Learn, the Pandas library, and all that things. We covered everything that we thought are like more useful and practical. Now I thought it's a really good time to start talking and focusing only on machine learning algorithms. And I also promised you in the previous tutorial, the last topics tutorial, that I will be teaching you more about the different algorithms. So what we will be doing here in this tutorial is that we're going to implement the machine learning algorithms, the regressions, k-nearest neighbors, the support vector machines, and all those algorithms from scratch. So I'm going to teach you what each algorithm does. We're going to go over the basics of the algorithm. I'm not going to take too much time. It's just going to be very straightforward and easy, hopefully. And then we want to code that in Python and compare that against how the actual module from, SciKit-Learn or something like that would perform. Hopefully the performance would be the exact similar. Anyway, let's get started. So for today's video, I thought I'm going to start with something super easy. That's the k-nearest neighbor. How does that work? Let me explain that to you. So for k-nearest neighbor, let's say that you have like a data set, and you plot your data set based on feature 1 and feature 2, right? And you have some samples, right? Like you have, let's say you have 2 classes in your data sets. And so this is one class, and then the other class is, for example, these are the data for the other class. And now you get a new sample, right? The new sample comes in here. And you want to classify that. You want to say if this new sample belongs to the black category, which is this category in here, or the yellow category. You don't know, right? You want to classify that. So what k-nearest neighbor suggests is that it says measure the distance between the new point or new sample, which is this guy in here, to all the previous samples that you have. So measure the distance between these and this as well, and then also these ones, right? Measure everything, right? And then choose the closest 3, or choose the closest k. I said 3 because most of the time, we go k equals 3, right? But that's not really a thing. Use the closest k neighbors, right? In this example, I want to say that, for example, let's say this is my closest sample. This is the second closest. And then let's say, for example, this is the third closest. And in this example, I'm assuming that k equals 3, right? Just for the simplicity. So these are the closest samples, the 3 closest samples that I have. Then I look into these samples. I'm saying 2 of these 3 samples belong to the yellow category. Because the majority of the samples belong to this category, then I want to say that this new sample also belongs to this category, right? If you had 2 blacks and 1 yellow, it would obviously be the other way around. You would predict that the new sample is closer to the black sample, so it would be probably in those category. So that's about it. That's about the basics on what it means. And now we can actually start coding in Python and see how we can implement that. So if I open my Visual Studio Code, I'm just going to go import NumPy as MP, as always. I want to, from SciKit-Learn, I'm just using SciKit-Learn for the purpose of 2 purposes. First of all, I want to load the data sets because, SciKit-Learn has some data sets in it. And I also want to use it for comparison. I want to implement the k-nearest neighbor model of my own and then compare it against what SciKit-Learn has. So from SciKit-Learn, import datasets, and then neighbors. I also want to, from SciKit-Learn, that's not SciKit-Learn, SciKit-Learn, import, let's go dot model selection, import, we've seen this before, train and test split, right? So these are the things that I want to import for now. I may add to this later. So first things first, let's load the dataset. I'm going to use the iris dataset as we used in the advanced course. So X iris and Y iris, that equals datasets dot load iris, right? And if you remember, I'm just going to go return XY equals true. So now we have our main data. X iris be our training data and Y iris be our labels. And because we're using a supervised learning model, we're going to actually use these for training purposes. Because as I said, like we have to measure the distance between the samples. Anyway, now let's have our X train, X test, Y train, and then Y test. That equals train test split, X iris, and then Y iris. Not what I wanted. So this guy, and then we want to go test size equals 0.2, for example, right? So the 80%, 20% rule that I said. So we have our data set loaded, and then like we have our training and test data ready. So if you want to use the SciKit-Learn model, right, I can just go, for example, a variable name, neighbor. I want to create an object, right? I just want to go, it's like neighbors. This neighbor is the thing that like we imported here. Dot KNN neighbor classifier, right? And then here you specify the number of neighbors. That equals, let's go with 3, for example. And then all you need to do is to go neighbor.fit, very similar to what we've seen before. And then you want to give it xtrain. And then again, because it's a supervised learning method, then you need the Y chain as well. And then the predicted values, you can go Y iris underscore or predicted or whatever. That's equal to neighbor dot predict X test. You give it the test data and it returns the predicted value. Now you want to measure the accuracy, right? Here it can go accuracy equals 0, something that we've done before. And now I want to go accuracy equals, I want it in percentage, so 100 times NumPy. This is actually like a new method of doing this that I'm showing you. So instead of like defining a for loop and everything like that, we can do this. I'm saying NumPy.sum, like add everything there, Y iris underscore equals Y test. So it says whenever like Y iris, wherever Y iris is equal to Y test, like compare the elements one by one. If they match, then add 1 to accuracy. This is basically what this line does. And then like we multiply that by 100, and then we divide that by length of Y test, which is like the test samples, and it gives us the accuracy, right? And now I can just go print our print statement, accuracy using SciKit-Learn KNN model is And I just want to print accuracy here, right? All good. Let's just print that, run that, see how it works. It says invalid syntax. Oh, yeah. I'm just, because we're in Python, that's why. So I'm just gonna quit here and clear that and run this. And it says the accuracy is 100%. It's an easy data set. The accuracy is like 100%. So if I increase the number of neighbors to 5, for example, because now it's like measuring, like considering more samples, it's more likely for it to make mistakes. I want to run that again because like it gave me 100. And again, like because it's like using some randomness in the algorithm, it's actually like every time you run it, it gives you a different value. So it's just like now it's like 96%, 96.66, which is okay. So this is like the K nearest neighbor from the SciKit-Learn model. Now we want to do something else. We want to define our own, right? So let's just comment this out. We'll bring it back later for comparison purposes. We wanna define our own class actually that does that, right? So I'm just gonna define a class. I've showed you before how to define a class, so it should be okay. If not, go back to the advanced videos or maybe like the beginner tutorial. I don't remember exactly, but anyway, I'm just gonna name it my KNN, for example, my K nearest neighbor. And as always, we have like the init method, underscore init underscore, and then it has self because it's a method of the class, and then K, it's a K nearest neighbor, and I'm just gonna give it the default value, like 3, for example. And I'm just gonna go in here, I'm just gonna go self.k equals K, right? So far, so good. What other functions do we need? We need to have probably a fit function, right? I'm just gonna go define fit, and that, because also it's a method of this class, it gets self and it gets y, like the x values and the y values, and we can keep adding to these methods as we go because we don't exactly know what we want. Well, let's see how it goes. So I'm just gonna go self dot xtrain equals x, and self dot ytrain equals y. There is a reason that I should like use uppercase for this guy in here, and I'll show you later why I'm doing this. But it doesn't matter. At the end of the day, it's just a variable name. So that's that. And then I want to have define, I want to call that underscore predict, right? Because I want to have 2 predict functions or methods. One is just like to compare, like to predict one sample, and then like one to compare and like predict all the samples, like for the test sample. We'll see in a second. So underscore predict is just like a temporary, well, not really temporary, but like a smaller function just to predict one sample. So I'm just gonna give it the self and x, right? And how it works is that I'm just gonna go all distances because we have to measure the distance of this new sample with every other samples that we have. So I'm just gonna create an empty list, do the measurements, and then like put all the distances in here, right? So I'm gonna go for x train. Like this is why like I use capital X here and x train here, because like now it's like referring to one sample in the x train, right? For x train in self dot x train. So in all the training samples that you have, do the calculation, right? I'm just gonna say d equals, right, the distance, numpy dot sqrt. So you want to get the root mean square of numpy right? The sum of, let's actually, because like it's getting like complicated. I want to define a function to do that for me. I want to go define calc distance, right? Calc dist, and then I have x1 and x2, 2 points, right? The distance between these two, what is the distance? It's numpy.sqrt. We want to get the sqrt, like with mean square of what we need to like measure the distance. And how do we measure the distance? You subtract the values and like square that, right? For all the coordinates of those values. So numpy dot sum, and then here you go x1 minus x2 that squared, right? That should be it. And then we want to return this. If you didn't like the function, you can just like, it's a one-line function, right? I just put it up here so it's like cleaner. You can actually like have it like in a single line in here. But now here it can just go, instead of this, do the calc distance of x, right? And x train. X train is all the samples. It's a for loop, right? All the samples in the training data set, and I'm like measuring the distance between the new sample and each of those samples. And then once I have that, I'm just gonna go all this that append. I'm just gonna add all the measures here, or all the distances here. So now I have all the distances, right? And the next thing I need to do is to like sort the distances, right? And choose the k closest ones, which is basically the k smallest value. So I'm just gonna go k index, right? It's just like enter here so we see better. K index equals numpy dot art sort. That basically sorts my value on my list. So I give it all the distances and I sort it, and I want to get how many? The k closest or the k smallest values. And we already know how to do that. Like I'm saying, from the beginning, after you sorted everything to self.k. I misspelled self.k. So this has the index of the closest, like the k closest neighbor, right? Now I can go, now I want to know like each, like which class does like each of these, neighbors fall into. So I'm just going to go k neighbor, right? It's an empty list. And I'm just going to go for index, for example, in k index, because like these k index is the same thing in here. It has the labels that we want. And I want to go k neighbor that append. What do we append here? We want to get the labels, right? So where do we have the labels? We have them in self.y train, but which ones? The IDX ones, right? So here we have all the samples. I'm just going to explain one more time. Here we have all the samples, like the closest samples, and I'm getting like by Y train index, because index is looping in here. I'm getting the class of each of those neighbors, the closest neighbors. And now that you have that, now we have to choose the most common one, right? So basically what you can do is to look into this, see what you have, right? And then choose the most frequent sample. There is like a lot of ways in that. You can like make it a set. The set is basically like saying, like if you have a list of 1, 2, 2, 3, right? So like 1, 1, 2 2s and 1 3s. And then you set that, it returns the unique value. It says it's 1, 2, 3. And then like you can count the number of like each sample in the set version. Like there was a lot of ways, but an easier way that Python lets you do that is this. So I'm just gonna import from collections, we import counter, right? It does the job for us. So down here, I want to go selected class, for example, or category or whatever you want, equals counter of k neighbor, right? And return the most common one, right? And most common, only like one sample. If you do like 2, then it returns like the 2 most common values. So I just need the most common one. And it returns an array. So I'm just going to go 0, 0. So it's just like the first one that it returns. I want to get that. And then I obviously want to return the selected class. Okay, so far, what do we have? We have the init method, we have the feed method, and then we have predict that only predicts one sample against like all the data set. Now it's time to add like the actual predict. So I'm just gonna go def predict, right? And this also gets the self and the capital, I think we called it capital X, right? Yes, capital X, which is like our test set, right? So in here, what we can do is that we can go ypred the predicted values that equals. So we can basically have a for loop and call this function, the underscore predict, inside each iteration. I'm just going to close this so it gives me more space so you can see actually. But also like you can do something like what we did for the accuracy up here, right? Do this, right? Something similar to that. So let's actually learn how to do that. I'm just gonna go, it's a list, but inside the list, I'm gonna go self dot call the method that we have, underscore predict. You see it has that automatically. Call the underscore predict on X. But what is X? I'm saying for X in X. So basically all it does is that it takes all the elements in X, like a for loop here, right? For X in X. And then like does the calculation here, like run this method on it and append the value to ypred. And then what we need to do is to return numpy array, in case it wasn't a numpy array, numpy array of, well, it actually is not because it's an actual list, but we want it to be numpy array because everything else is in numpy array. So ypred. Cool. So this should be good. We have all the methods that we need here, and it should be okay. Let's actually see if that works now. So we can close this. We can close that. We can bring Volbe's back because we want to compare the results. Right? Okay, now let's see how we can actually use that. To use that, I'm going to go define a classifier. Classifier equals, now we have this class, so I'm just going to use this class, right? And in my class, k equals 5, for example. If you don't provide anything, it's going to use the default value, which we set it to 3. Anyway, so the CLF is my k, and it's like an object from the class that I defined, right? Now I want to go CLF.fit, and I'm going to give it the X train and obviously Y train, right? And then I'm going to go ypred underscore. These are the predicted value. That's basically equal to CLF dot, not underscore predict because that's one sample, but the actual predict, and it's going to get the X test, right? And now that we have that, we can actually measure the accuracy. To measure the accuracy, I'm just going to copy this line so that I don't have to write everything over again. So accuracy is 0, numpy.sum, not yiris, but ypred underscore. Wherever that equals to ytest, then add 1, and then like do the calculation, and then divide by length of test. And we have the 100 to make it a percentage. And everything looks good. And this is not the SciKit-Learn. This is our KNN model, right? And if I run that now, it's not happy with something. It says, let's see what the error is actually. It says sqrt numpy, oops, that. It's not happy with that. Where do we have that? Yes, it's saying like there is no star here. I might have accidentally just like put it there. Let's see if that fixes the problem. Cool. They are exactly the same. It says SciKit-Learn KNN model accuracy for that is 96.66. That's the same accuracy that we get. So we could successfully implement our own KNN model, right? If I run that again, 100%, they match. That's okay. Looks like it's following 96% again and 96%. Run that again. Like you can keep running it and you can see that like you're getting different values, 93.33 now. So this is, it's good that they're matching. So we have like the exact same models. But what is not really good here is that these results are not reproducible. Sure, like a lot of time we were saying 96.66, so that seems to be the most like common result that we get. But this is not really good practice in programming. If you have an error sometime, right, you want to be able to reproduce that. And here, maybe sometimes, like for example, let's say if the accuracy goes below 93%, I may or may not get an error, right? I mean, I won't in this case, but let's say that happens, right? And you want to fix that bug. If you have to keep running your code like, I don't know, 1,000 times to hit that bug again, it's a torture. It's a pain to fix that bug. So it's always like a good practice to set a random seed here. And by setting a random seed, you are making your design reproducible. So I'm just going to go numpy dot random the seed. And I set it to 0, for example, or 10 or whatever. You can read the documentation in this to see how it exactly works. But if I set it to 0, right, and if I run my program again, every single time that I run it, I expect to get these values. So there's not going to be like 100% accuracy or 93.3 accuracy, right? It's always going to be this. We can see, like if I keep running this a few more times, it's going to be the exact same value. You can write this code. I'm like, put it in a for loop and like repeat that for like 100 times to see that it's not going to change the result. Anyway, that's about the k-nearest neighbor algorithm. I showed you the math behind it and how it works. I explained it to it, and we implemented our own model. Right? We have a class that does it. So instead of using SciKit-Learn, now we can use your own class. Well, that's enough for today's video. Thank you again for watching me. Please don't forget to subscribe to my channel so that you support me and you get notified when I upload a new video. You guys have a good one. Take care and see you in the next video. Bye-bye.